Wonderful, wonderful. Well, I gave my impression of what NTP does for me, but why don't you go ahead and give us the 30,000-foot overview? What is NTP and why is it important?
NTP keeps the clocks right on computers, and it does this based on the premise, if I'm speaking for the machine, NTP works on the premise that I'm saying I want to know what time it is. I'm going to ask other sources what they think the time is, and based on how many answers I get, I'll decide if they're sane and follow the best idea I can of what time I believe it to be from looking outside me.
Well, you know, back in the early days, I knew that you could do some sort of, like I used telnet to a port. It told me what time was on the other machine.
Yes.
Why do we need NTP on top of that?
Because if you go to telnet to the time port, you don't know there's going to be delay and latency. Telnet TCP has retry and it gets messy. So the beauty of doing time with UDP packets is there's no retransmissions and you can get the time much better. Back in the early days when Dave Mills first started to work on this, he considered himself lucky if he could get a machine to follow accurate time to within 1/10 of a second or so. And we knew we could do better as time went on and we learned to distinguish the different sorts of jitter and noise that were in a signal. And to everybody's credit, we've got that down from the millisecond range, to the 1/10 of a second range, down to easily the millisecond range for LANs and the microsecond range if you need to. And with other protocols, including NTP, using some other techniques, NTP or Precision Time Protocol, PTP, we can get time synchronization down to a handful of nanoseconds.
Wow, that is purely amazing. So as I said in the opening of the show, you know, your first hop or second hop might be in the order of milliseconds. My understanding of NTP, and you can correct me, I'm going to do sort of the high-level hand-waving, is that I send out a packet and I have my timestamp in it, then you get it, and you add your timestamp to it and send it back. And then I can use the two other timestamps to figure out how long it took to get there. Is that a good overview?
That's close. The final timestamp packet you get has 4 timestamps in it. T1 is the time you sent it. T2 is the time I got it. T3 is the time I sent it back to you. So if you subtract T3 from T2, you're going to know how long I processed it. And T4 is the time you received it. And so you can do some interesting things with subtraction there. And if you assume a symmetrical connection, you can then say the delay for you to send it to me was the same as the delay for me to send it back to you. And you can go ahead and use that to calculate the time. And it doesn't matter if my clock's ahead of yours or if your clock's ahead of mine, or our clocks are running at slightly different speeds. If you do these things often enough, it's possible to take the information and make sure that you can steer your clock toward where you want it to be.